All right. Let me share my screen. That should be on a bumper sticker somewhere. Let me share my screen. All right. Well, hey, everybody. Nick Furman here. Thanks so much for watching this short video, which will be a bit of a crash course in statistics. I was asked to put together a brief presentation to give you a little background on some of the analysis that was done with the FACS statewide needs assessment data. This is the outstanding world of statistics. I know you're surprised that I came up with that. And the fact that stats really aren't that awkward at all. Take a look at all these beauties on the screen right here. All these wonderful birds of prey, aside maybe from this raven right here and vulture. Most are birds of prey. I want to introduce you to a data set today to help you see the value of statistics from the world of birds. And we're going to apply what I show you with stats and birds of prey to the FACS statewide needs assessment data. I think this will warm you up to statistics. I think it's a very interesting study that I'm going to reveal to you. It's an area that I work in quite a bit, which is animals and education. It's pretty interesting stuff as well with regards to empathy or concern that others have for birds like those on the screen. So let's jump right into this and we'll fly right along, right? So the first thing that I want you to know is that there are really two types of statistics that we talk about. The first type really is the most basic, and it's the one that we often forget to do because it is so basic. We jump right to the most advanced, the most sexy statistics out there, but we often forget the basics. And the basics are called descriptive statistics. Descriptive statistics is what would go in that first blank right there. And they are statistics that describe our sample. What did it look like demographically? What was the breakdown, male, female, urban, suburban, rural, salary, all the different kinds of variables that might describe an individual, height, hair color, kind of car you drive, whatever you want to put up there, that's a descriptive kind of a statistic. And oftentimes percentages or averages or modes might be used to describe that. And it's often, like I say, the most often forgotten piece, but to me, it's the step one when we're reporting data. Let's talk about the type of sample that we had before we get into the fun stuff. The second type of statistics is called inferential statistics. And inferential statistics help us make inferences or best guesses using a sample about a population. Because we can't ask everybody in Georgia to complete the FACS needs assessment, we got a representative sample, we think, and we're going to use that sample to infer or make a prediction about the population. Just the same way as a meteorologist would make a prediction about where a hurricane is going to go, they are making a best guess based on data that they already have. So using the present to infer about the future. So descriptive stats, inferential stats. We're going to talk about both of them today. And I want to tell you a little bit about this study that I'm going to talk to you about that involves birds of prey. There's my buddy, Jeff Ewelt. He directs a zoo out in Montana. He's a great buddy of mine. I met him down in Florida. We were doing some work together with birds of prey, like that beautiful barred owl that Jeff is holding right there. So this study that we're going to use today to talk about stats involves three groups of birds. The first group of birds that an audience, a series of audiences were exposed to were birds of prey like owls and hawks and falcons and things that had visible injuries. A lot of times these birds come into captivity because they've been hit by cars, run into fences, power lines, different things, and they have visible injuries, missing an eye, missing a wing. It's obvious why that bird's in captivity and why maybe Jeff is holding that bird. And so that's a visible injury. So there was a group of individuals that experienced a presentation that had all injured birds of prey, visible injuries to those birds. That was group number one. Group number two, a series of audiences got the same species of birds of prey, the same kind of owl or hawk or falcon, but these birds had no visible injuries, nothing physically wrong with them that you could see. Many of them were imprinted or raised in captivity and were being used as a teaching tool. So you had a group of birds, same species, that had no visible injuries, non-injured, we're going to call them. And then you had this third group down here that was just pictures of birds of prey. Same species, but just a picture. And the pictures were of a non-injured bird, just sitting there. Jeff, my buddy there, did all the presentations that were of injured birds, those of non-injured, and those with just a slideshow, pictures of birds. And he did these with audiences of individuals in South Florida who were the snowbirds, who were down there, retired individuals that were a captive audience for us to go and present with these birds. And it was such an interesting study to do. But I want you to remember, we have 3 groups that we're going to be comparing and talking about today. Just the same as with the FACS data, we had multiple groups, 3 or more groups of people that we could make comparisons against. For example, urban, suburban, rural, just to keep it really simple. How did they differ where they live currently in their stress level, for example? And so this is just an example we'll use today involving birds in one of my passions. So there's Jeff, there's our 3 groups that we're going to talk about. Let me show you just a little bit about the questionnaire that was used, as old school paper-based questionnaire, because these are some older folks and we didn't want to introduce technology to them there. But they had to tell us some things about demographics, the year that they were born, their male, female, what permanent city and state are you from? Because many of them were snowbirds coming to Florida. Did they have pets? Did they belong to a conservation or environmental organization? They told us some things about themselves. And then we also measured their feelings toward the birds using this existing, what we're going to call construct, or group of similar items that are measuring one thing. We measured feelings of empathy, the concern that these individuals had for the birds, and we did it with 17 items. Here's a couple of the items, a very simple word that they then have to respond to as you viewed the birds. Did you feel alarmed, grieved, sympathetic, troubled? What were some of those feelings that you had toward those birds? And notice the scale. We have a 1 to 7 scale from not at all to extremely. Take a look at some of the other items that comprise those 17. Take a look at them. We're going to get back to this in just a bit, because if you look real carefully, some of these items are quite negative, where others are quite positive. Take a look at number 16, compassionate, is a lot more positive than number 17, which is upset. We're going to talk about what that means in terms of our scale in just a little bit, but I wanted you to see the scale. I wanted you to know what the word construct implied, a series of items put together to measure one thing. And the reason we do it, very simply, people are hard to measure. And if we had just one item to measure their feelings of empathy or concern, that would be a lot of confidence we're putting in one item. We have 17 items to measure empathy in this case. And with the FACS needs assessment data, same kind of deal. Multiple items put together to measure one thing, because people are hard to measure. All right, so anytime somebody's talking about a construct, you'll know what they mean. Hey, we can't just do it with one item. I need a series of them to come together. So those are our 17 items. I want to show you what we found in terms of some of the demographics. So when we go in with the FACS needs assessment data and start measuring some of those things, those descriptive stats, take a look at some of the descriptive stats on our older people and the birds of prey. So you take a look at this, there were 213 older folks that participated in this study across the 3 groups, a total of 213. Take a look at some of the places where they're from. Obviously, Florida was a home for 129 of them, but look, Canada, Massachusetts, Ohio, some of those colder places, they're coming down south. Look at the breakdown of male versus female, more females than males there, just to give you an idea of what descriptive stats looks like. And this is the kind of thing that is step 1 for the FACS needs assessment data that we have. We're going to start by describing, and that's what's happening here. Take a look then again at the construct. So this is an example just to show you, here's 17 items, okay? But some of these items, 4 of them, numbers 11, 15, 16, and 20, are all very positive items if you look at them. And we're saying that those 4 items are associated with compassion toward the birds, a positive feeling as they viewed the bird. All the other items, the other 13 items, were quite negative. And we called those, they were disturbed by the birds. This is a negative feeling toward the bird based on looking at it and listening to Jeff talk about it. kind of an interesting thing. The thing I want you to pay attention to, the scale goes from 1 to 7, from not at all to extremely in terms of that feeling. Because we have 4 items that are negative, or excuse me, 4 that are positive, the other 13 that are negative, we might have to think about reversing those positive ones when we look at the data, when we interpret the data, for example, with an average. If we were to look at an average across that scale from 1 to 7, we want to reverse that scale when we interpret it so that, as I'll say in a second, all the fish are swimming in the same direction. In other words, and we'll get to that in a bit. Let me show you what we do to determine if those fish are all swimming together. We get a statistic called an alpha coefficient. There was a guy by the name of Cronbach that developed this statistic, and now he has his name associated with it. So Cronbach's alpha is a measure of how consistently the items are working together. How consistently are those older folks responding to the 17 items? Are all 17 of our fish swimming in the same direction? Or do we have a couple of them, like this little rogue one down here, that are swimming in a different direction? I will tell you, before we ran Cronbach's alpha in SPSS, which is what we did with our FACS needs assessment data, before we did that here, we had to reverse code those 4 items because we had 4 fish naturally swimming in a positive direction. The other 13 were swimming in a negative direction. You see what I mean? So this Cronbach's alpha, once we adjust that scale and we look at how well are those items working together, we're looking to see 0.7 or above. 70% of the time, in other words, people responded consistently. In our case, 92.3% of the time, you see how I got that? 92.3% of the time, those old folks responded consistently. They interpreted those items consistently, which is a good thing. And it's important to say our instrument, our tool, is working well. And we did that with our FACS data. In fact, as Dr. Brown will share, we used some existing scales that had been tested before, some existing questionnaires, revamped them a little bit for what we did in Georgia, which is a best practice. So take a look. 92.3% of the time, people responded consistently. That's great. That's above the 0.7 for sure. That means we can move forward. We don't have too many rogue fish in our little school there. They're all going in the same direction. The one cool thing, though, that we did in SPSS with our FACS data, and I want to show you here, there's a really neat feature that says, okay, if you got rid of one of the fish, if you got rid of one of the items, what would it do to the other items? Did you have an item pulling the whole team down? You know, did you have one that was kind of holding them back? This column right here at SPSS will tell us if we got rid of an item, what would it do to our Cronbach's alpha? Would it go up or down? And in our case, you remember 92.3 or 0.923 was our alpha value. Notice most of the time, my goodness, if we got rid of one of these, it's not going to be making that big of a difference. But with our FACS data, we took a look at this to make sure we didn't have a fish that was going the wrong way. And maybe if we removed that fish, we would do a better job at interpreting the data. It's not to be biased, it's just to be doing a better job with interpretation. So I wanted to show you that. That's looking at a construct, series of items put together, and how consistently are people responding. I want to talk about 2 groups for a second, because we very, very often in a lot of data have 2 groups of individuals, male, female, urban, suburban, rural, urban. I mean, all different kinds of 2 groups that we can look at. And when we look at 2 groups, we often use a thing called a t-test, T for 2. We did some t-tests with our FACS data, and I want you to take a look at what's on the screen. In this case, this is some real data, kind of different than the birds data, but I grabbed it because it's interesting. These are feelings of anxiety that folks have. Take a look at what's on the screen toward anxiety if you're in a public high school or a private high school. How much anxiety do you have about academic success and achievement? Here are our 2 groups, public and private. Look at the means, even without knowing the scale or anything. You got a mean of 13.34, we'll call it. You got a mean of 12.59, we'll call it. Fairly similar in means. Well, with our FACS data, we had a lot of means like this, two groups that had an average. Let's see if that average is likely to be different of the whole population. Here comes our inferential stats. We're going to make an inference about a population using our data from that sample. We've got 13, we've got 12.5. Let's see if we are in fact likely to see that difference in the population using a t-test. And if we take a look at this, here's what I want you to know. In this case, I'm going to look at a t-value on my little printout, and I'm going to look at, this is called a p-value right here under that sig column. And what I'm generally looking for, if I'm on the hood of a truck in the middle of a field and somebody says, hey, is this significant? Is this finding likely to be true of the population? I'm looking in general for a t to be above 2 and a p-value in general to be below 0.05. Take a look at the t-value, 1.6 we'll call it, didn't get to the 2 mark, and look at the p-value well above 0.05. In this case, this is not a statistically significant difference. This is likely not to be true in the population. Something's going on in the sample. Kind of interesting. We'll do it to you again. Take a look at another group. Time management. Concerns and anxieties related to time management if you're in public or private school. Take a look at the means here without even knowing the scale. 7.94, 7.14. Is it enough? Is that difference enough to be true of the population given what you found in your sample? Let's run that t-test. Let's see if the t is above 2. Let's see if the p is below 0.05. Without the arrows this time, take a look at our t-value. We'll use this one right here. T slightly above 2. All right, the horse has cleared the jump. The horse has cleared the fence. And take a look at the p-value. Oh yeah, we're a little bit below 0.05. What we're saying with this, our conclusion, yes, there is evidence to suggest a significant difference in those two groups, public and private. Yes, evidence exists to suggest a difference exists. Notice I don't use the word this proves there's a difference. This is just suggesting a difference. A lot of things could be going on there in terms of why, but at least our data is saying there is a significant difference. Kind of cool. That's comparing two groups. Let's talk about what do you do when you got 3 or more. And I'm going to go back to the birds data now for that. Take a look at 3 groups. I want to remind you, we had injured, non-injured, and we had a pictures group. Non-injured was number 2, injured was number 1, pictures was number 3. So you know where your codes are over here, 1, 2, and 3. Take a look at your means. That mean is the average empathy score. Feelings of concern toward the birds, with the higher the mean implying the greater concern. Higher the mean, greater concern. Take a look at this. And I had to relook at this a few times to make sure I didn't make a goof up. Group 1, injured. Group 2, non-injured. Group 3, pictures. Look at group 3. Look at the jump that happens in group 3, the pictures. This is suggesting that those individuals had greater concern for the pictures of the birds than they did for either the living in front of them, injured or non-injured. Interesting, isn't it? We believe that may have been because they were distracted by the live birds and maybe weren't listening to the story of why they came into captivity and all that, but they actually had more concern for pictures. Quite interesting. I want to see if this is significant of a population of older folks there in Florida. Let's make that educated guess. And we're going to do it using an analysis of variance, Anova. We did this quite a bit with our FACS data. In our case, all Anova is doing is saying for 3 or more groups, is at least one of the groups likely to be different? Take a look at this. To know if there's a significant difference in general, we look for an F value, this little F value, it doesn't stand for Furman, I wish it did, but an F value above 1. In our case, that F value is quite a bit above 1. And when we look at that P value, there's that sig column. Boy, that's well below 0.05, doesn't even register. In this case, there is a statistically significant difference among one of those 3 groups. And look, just to put a little common sense in this for you, which group do you think is the one that's different? 1, 2, or 3 based on the means? I'd say it's number 3, wouldn't you? That is really jumping out. And that was a significant difference. And that really led us down a trail to wonder why. And we really believe it was because the live birds distracted from learning and that concern, and very interesting. For a person that loves live animals and education, it was a little bit of a kind of a moment, but look at the learning that can occur even with pictures and the concern that can be brought about, empathy with pictures. Pretty cool stuff. So some take-home messages just over these couple minutes as we spend together about stats. Descriptive stats describe, inferential stats help us make inferences using a sample about a population. And the 4 biggies that we talked about today that you may see in some of the printouts with the FACS data, 0.7 or above for our Cronbach's alpha. How consistently are those fish swimming together? Are those items working together? T above 2 typically tells us there's a significant difference. F above 1 typically tells us there's a significant difference among 3 or more groups. T for 2, Anova for 3 or more, and then remember that P value. Something can be significant if it's below 0.05 in general, but when we talk about that, the further below 0.05 something is, the greater the evidence, in support of a difference. It's not that one thing is more significant than another. It's black or white. It's either significant or not. It's that strength of evidence. I use that word, that's a very important one to use. So that's some cool stuff right there. Gang, I hope you enjoyed this. I know it's a crash course over just a couple minutes, but it's something I enjoy. I hope you did too. You can go back and rewind and rewatch if you need to. If you have a hard time sleeping at night, you can do that too. Thanks for watching. I hope it's helpful. I hope to see you soon. Bye.